Great. So last week we did see the CIA triad, and we said that it's one of the core concepts of cybersecurity, where it consists of the confidentiality, availability, and then integrity, okay, of the system. And then somebody asked if accountability or non-repudiation was part. I was like, yeah, it's part of it, okay, but that triad is just the CIA that we are seeing: confidentiality, integrity, and then availability, okay. Then we have zero trust, where it was explained that users, or let's say devices, are taken through the right process or the right verification processes, and then no device or no user is actually ignored under no any circumstance. So that is zero trust. You go through the laid down processes regardless of who you are or the location or what you are, okay. Then we have least privilege, where we actually give people the minimum privileges or the minimum permissions necessary for them to perform their functions, okay. So a typical example is if you are working in a company and then your job is to be maybe at the front desk. Yours is just to attend to people coming to making enquiries, and maybe if they are coming to make any form of payment, you accept the payment and then give them like receipts or any kind of report. That is going to be your job. So for permissions, you are only assigned permissions to do that job. You don't have permissions to work on the next floor where management is working. Neither do you have permissions to go to the top floor where we have maybe the like bigger authorities in the company are actually working. Yours is just the ground floor, okay. That is the permissions you actually assign, okay. That is when it comes to companies and the physical things. When it comes to softwares, okay, if you are using a particular application and as a normal user, your role or your responsibility is just to be able to view and then read certain things, then that permission should be given to you, and then nothing more should be added. We shouldn't say oh, this person has used the application for a very long time into a man of permissions to be able to edit files. No, that is not your role. That is not your job, okay. Your job is just to be able to view certain things, and then that is it. We shouldn't give you any other permissions. If we give you any other permission, then it means you doing a particular job, you have been promoted to a particular maybe role, or a particular, you've been given a particular responsibility. That is why we are adding that permissions to you. But if that is not the case, under no circumstance should you be given more than necessary permissions to perform a specific task, okay. Then we have defense in depth, where defense in depth talks about you having multiple layers of security to actually protect a particular infrastructure, okay. So you have different layers of security implementation, security tools implemented in your network, okay. Now defense in depth is good, and I'm sure most of the times you hear in movies where they talk about, maybe you see hackers saying that they've been able to break through their firewall, it's left with maybe breaking through the next layer of security. Those statements that they make is just an indication of what we call like defense in depth, where the company is using multiple layers of security to protect its assets. So from the internet to the company, you have a firewall that is actually blocking your access. Immediately you bypass the firewall and then you get to the company's network, you would have another system that is also going to be blocking you. And then on individual systems, you have antivirus programs that is also running on them, where you would also have to bypass. And then when you bypass those antivirus systems to access specific files or folders, you need to go through a multi-factor authentication process. So by the time it will take you to even get to that stage, because in the field of security and then looking at cyber attacks, we are not actually going to say that you can have a particular company 100% protected, because there's not going to be any such thing like 100% security, or maybe a company is protected 100%, okay. You wouldn't have that done. But what we normally do, or why we actually implement these security measures, is just to increase the time it takes for attackers to get into a system, not to protect the system 100% complete, because it can't happen. It's not going to happen. There's no system in this world that is even 100% secure. Even performing let's say coming up with machines in integrated science, you are being told that the efficiency of a machine is never 100%. Not protecting the machine, you with a human being protecting a system or a machine, you can't give it 100% security and say that, oh, this thing is 100% secure. Okay, it's not just time for your system to be hacked, but if it's time for your system to be hacked, when it's time for your system to be hacked, it will actually be hacked, because it's just a matter of time how persistent an attacker is on your network. Okay, that is just what we actually up against. So if it takes less time, or if you don't have multiple security measures implemented, it takes less time for your systems to be hacked. If you have multiple ones and then they are done well, then it takes a longer period. Okay, so you'll be able to work for a longer period of time. But if you don't, it's just going to take some few minutes or some few days, and then you are doomed. Okay, then we have security posture, which is actually an organization's overall cybersecurity readiness and health. Now, readiness and health means you actually analyze the devices and then how the company is when you talk about security, and how ready is it for an attack. Not like you are preparing the company for an attack, but you are analyzing to see, say, at this state right now, at this position of this company, if there is going to be an attack, what are the things that this company has to protect itself from this attack? Or if there's an attack, can this company withstand whatever is coming? That is going to be a security posture. Checking the company security posture, just checking to see the necessary things they have in place to protect or to prevent some form of attacks. Okay. Any question? Any question? Alright, if there's no question, we move on to taking the CIA triad to talk about it. Now, the CIA triad, like I said earlier, that CIA part of the CIA triad is just confidentiality, integrity, and availability. So when we talk about confidentiality, what we mean by confidentiality is making sure that, or ensuring that, data that belongs to a particular institution or a particular entity or a particular group of people remains private between them, or it remains out of reach or out of the understanding capability of third parties. Clear? So like an example is maybe you and maybe your friend, you want to share some form of secret information. What you normally do to ensure that it's confidential or secret is that you discuss that information when there is no one around. That is one way you ensure confidentiality. In a situation whereby you realize that you and that friend trying to share something secret, you actually from the same maybe home, you have the same hometown, you understand the same language, and you realize that where you find yourself currently, people don't really understand the language, so you can actually share the information amongst them by actually speaking or saying it in your language. That is how you ensure confidentiality. That is, you are making sure that the data is actually sent, or that information is sent, but the people that have access to it as at when you are saying it don't really understand what you are saying, because you have done something to the data, which is actually one of the ways to make sure data or information is confidential. Moving on to something called encryption. Okay, so we encrypt data to make sure that that data is actually not meaningful to unauthorized individuals. So you saying it in your mother tongue, or let's say your hometown language, will make it difficult for somebody who doesn't understand that language to actually make meaning out of it. So they'll just hear it but wouldn't understand. Okay, so when you encrypt data and you have attackers on your network, they will be able to, sometimes they'll be able to see that data or that information, but the problem is, will they be able to understand it? If it's encrypted, no. You would have to do something called decryption, which is actually you reversing the encrypted text to its original text. So encryption is actually you transforming an original text into a different format that is not understandable by someone who doesn't have permissions or who doesn't have the right means to understand it. Okay, then the decryption is when you transfer or you convert an encrypted text to its original format. Any question? Any question? Any question? No question. Alright. Alright, so no question from Boam. Alright, so if there's no question, let's continue. If you have any question, let me know. Now, since there's no question and I've made mention of encryption, let's see what we can say about encryption. Okay, so under encryption, or anytime you talk about encryption, you would end up talking about some various types of encryption and then certain components or certain things that are required to actually encrypt messages or encrypt text. Okay, so we'll talk about symmetric and then asymmetric form of encryption. Okay, now if these are new words to you, don't worry, after some time you get used to them. Okay, but then what they mean in encryption is just, or it just has to do with how they actually do the encryption and the decryption. Okay, and we can't talk about encryption and decryption without talking about keys. So let me just get the notepad here. Okay, so so I said encryption, then we have, I think it's symmetric, asymmetric. Okay, and then all of them you would actually have to talk about something called keys. Okay, so that is what makes these two different. Okay, because it's based on the keys. Now symmetric encryption uses just one key. Okay, it uses one key to encrypt and then decrypt. Now these keys, right, this is the name given to the keys. The keys are actually two. The keys are two. There is the private key and then there is the public key. Okay, there is a private key and then there is the public key. It's something like this. Okay, now the difference between the key private and public is just the names here, private and then public. So a public key is the one that you can actually share with anyone. You can actually share this key, but a private key is a key you don't want to share with anyone. It's supposed to be kept private. That is why it's called private key. But under symmetric encryption, which is using just one key for both encryption and decryption, it uses the private key, right? It uses the private key. Now this private key is used to encrypt, at the same time used to decrypt. Symmetric encryption, one key for encryption, the same key for decrypting. Okay, now The next one is the asymmetric, which is the opposite of this. Now the asymmetric uses both keys, but how does it use those two keys? Whenever you want to encrypt a message using the asymmetric encryption algorithm, you need to use the receiver's public key. So let's say maybe let me check the names here. Let's say maybe El Shaddai wants to send a message to Sadiq. I think it's Sadiq. So let's do it this way. So El Shaddai, I don't know if it's this way, but yeah, so Sadiq. Hey Charlie, let me check the spelling. Yeah, so that is what, yeah, so Sadiq, so that's what I'm seeing here. So if that is what's going to happen now, what will happen is that before the chat happens, right, let me use this platform for before, like let me use this one. So if I go to draw.io, I think that would actually help. I'm trying to do some drawings here. Zoom, where is the zoom? Alright, so I don't think I'll need this. I don't think I'll need this. Alright, so let's have El Shaddai here. And then let's have Sadiq here. Okay, these two people are trying to have a conversation, right? So they are trying to have a conversation. Which is actually going to be like this. Okay, now before the communication actually happens, right? Before the communication happens, something happens. There's going to be a key exchange. Okay, there's going to be a key exchange. Let me go to, I think it was, oh come on, view, edit, arrange. Voila now. Yeah, so there's going to be a key exchange. I was trying to like write the names on the top here, but I'm not finding the text. I think this is edit. This is the basic, advanced, UML. This is arrange, view, edit. There's supposed to be text somewhere. I don't know. Yeah, so I got it. So let's make it El Shaddai, and let's move El Shaddai here. Then let's make Sadiq, and let's move Sadiq, come on, here. Yeah, so now we get to see them. Okay, so let me try and see if I can zoom in. Yeah, there's going to be a key exchange. If it's El Shaddai that wants to send a message to Sadiq, right, what she's going to do is, or what's going to happen is that Sadiq here will first send his public key to El Shaddai. Okay, Sadiq will first send his public key to El Shaddai. So Sadiq will first send his public key to El Shaddai. Then what El Shaddai would do is that she would use Sadiq's public key to encrypt the message she wants to send to Sadiq. Then she will send the message back to Sadiq. When the message gets to Sadiq's place, so let's say this is going to be the message. Oh, come on, not that one. Let's use this one, make it a bit smaller. So let's say this is the message being sent. Okay, so this is the message being sent. Okay, and this is the message received at Sadiq's place. Okay, so now this message is encrypted using Sadiq's public key. So when it gets to Sadiq's place, what Sadiq would have to do is decrypt this message. You will have to decrypt this message by using his private key. Sadiq would have to decrypt this message by using his private key to decrypt it. That is how asymmetric encryption works. So the two keys are being used. When you are sending, you use the receiver's public key to encrypt the message. When the message gets to the user, they use their private key to decrypt the message. Unlike symmetric encryption, where the same key, so the key is shared between the two of them, and then they just use the same key for encryption and then decryption. So most of the time, symmetric encryption is called shared key encryption, where the same key is shared, but with the asymmetric, you actually have different keys being used to perform the encryption and then the decryption. Any question? Any question? Yeah, ma.
I think I don't understand the public key. You said Sadiq will send El Shaddai is public key.
Yeah.
Like, what form is the public key? I don't know.
Is that? Hey, Charlie. Amakunedu, you are still here. Yeah.
I said, like, Sadiq would send El Shaddai the public. El Shaddai is public key.
Yeah.
And like how like how does the key like
I so
yes.
Alright, sure. So we have various algorithms under asymmetric encryption. Okay, so let's say the most common one is the RSA. So based on the algorithm, you would have a different key format. Okay, so for instance, if you search for asymmetric encryption algorithms, right? Yeah. So we have the RSA, ECC, Diffie-Hellman, and then the DSA. Okay, common algorithms include, so if the most common one that is available is just the RSA here. Okay, so a typical RSA key would look like this. RSA public key. I'm just trying to generate one so that you see how it looks like. So I just go to this site and I click generate key. So it's going to generate a key, and this is how a typical public RSA key looks like. So this is the key that is being sent. Okay, this is the key that is being sent, but you, the end user, you mostly have no idea about what is being sent. This is done without your knowledge. It's the system that does it. So the idea, or what I can tell you, is that whenever you see that message from WhatsApp that maybe you are doing a key exchange, okay, the idea I can give you is that maybe you are exchanging your keys, your private, your public key with your contact, and your contact is also exchanging their public key with you, just to ensure what they call the end-to-end encryption, that thing. But mostly when we are using asymmetric encryption, we have these keys being used. So this is an example of a public key in RSA, and then we can have the private key here as well. So this is the private key too, and also seeing it here. This is how that one also looks like. Okay, yeah, so these keys are actually computed using some mathematical functions. Okay, that is why we specify the length here. Okay, if you read more on RSA, you get to understand like how it's being used. And then we have the ECC, the Diffie-Hellman digital signature algorithm, Gamma, and all those ones. So any other question?
Yes, please.
Yeah, let's hear your question.
Okay, well, for your explanation, you said should I use static public key to encrypt the message?
Yeah.
So my thing with the static, static didn't use should I public key, but he rather used his own private key.
Yeah.
So that's my question. Why didn't he use SHI public key? Like how SHI uses public key to encrypt the message.
Okay, so the how it works, that is like how the asymmetric encryption works. Okay, so the thing is, you can never decrypt a message that has been encrypted with a particular public key without its corresponding private key. So you realize that when I was generating the keys, it didn't generate just the public key, it generated with its private key, which means that the moment this message is encrypted using this public key, it's only this private key that can decrypt it, and then the public key cannot decrypt the message.
Okay.
Yeah, so you only need to decrypt the message with a private key.
Okay. So does it mean this is the symmetric for
Does it mean what?
Is this a symmetric encryption?
Yeah, asymmetric encryption.
Hello.
Are you okay?
Asymmetric. Okay. Is it asymmetric?
Yeah, asymmetric.
I thought the asymmetric uses two keys. When is the private and the public?
Yeah, that's what we are talking about here. Asymmetric. So public key and then private key.
Okay. Okay. So if we're symmetric, that means that use only one key.
Only one key. The same key for encrypting, the same key for decrypting.
Okay.
Yeah.
Thank you.
Alright. Magdalene.
Okay, so how will they share the keys? Are they going to share it online or because maybe somebody is also watching the network when they are sharing the keys, someone can see it online?
Yeah, so most of the times this key exchange, you the user don't even see it. It's just done, let's say, over the network, okay? And then if you are intercepting, or let's say you're on the network and then you get hold of a public key, like I've already said, you can't use the public key to decrypt the message unless the private key. But since the private key is not shared, then it's going to be a problem for you to decrypt it, unless maybe you and Kasano then what develop our algorithm, and then you didn't know how to do it, and then you made sure say the public key in Ankasa can be used to decrypt it, or somebody can generate the private key from the public key. But as at now, when you use the asymmetric encryptions, you use the public key. You can't use the public key for anything else apart from encrypting. You can't use it to decrypt. You need to find a way of getting the private key. So even if it's shared on the network, that is why it's called a public key. You can send it to anyone. But most of the times, applications that implement this kind of encryption, you don't see it being done. It's just done at the background for you, and then you are able to start texting people. They only tell you that they are doing end-to-end encryption, but you don't really see it being done. More behind the background or behind the scenes, they are doing some of these things there. Is that okay?
Oh yeah.
So it's the sender that generates both the public and the private.
Nah, so the site I visited is just something you'd use to demonstrate, to show people, right? But if you are using a system, it's going to be done in the system, so you don't see the keys being generated. So for instance, everyone here using a WhatsApp account has a public key and then a private key being generated by the application, but you don't even know where it's even located. The moment you take my number and then you open my chat to send me a message, there's going to be a key exchange. Which you don't also see it happening, because that is it's everything encryption that we are talking about now is being done in the background, so you don't see it happening. The woman was sending message WhatsApp so end-to-end encryption, which means the moment you send the message is encrypted, and then it gets to my place. The moment it gets to my place, it's encrypted, but because I have my private key, automatically it decrypts the message for me, and then I see it. So you don't have to go through the stress of generating these keys and say, oh, let's do this, let's do that. No. It's all done in the codes of the application, so you don't get to see them. This is just to give you an idea of what happens. Are you okay? Yeah, Magdalene.
So, these two exchange, which one is very safe? The symmetric or the asymmetric?
So it depends on what you want. You can decide to use
network link. What's that from? Something like
who is that? Someone is talking. Yes, so when it comes to deciding on the asymmetric encryption and the symmetric encryption, it depends on what you are up against. Okay, if you want to choose an encryption algorithm that maybe is fast, okay, when you have like to do certain things that are like fast, you will go with maybe symmetric encryption, because it's just the same key that is being used to encrypt and then decrypt. No wahala there. Okay, but when it comes to security, that becomes a problem for the symmetric encryption, because it's just the same key. So if your key is being shared over a network and then somebody has access to the network, somebody is maybe sniffing the network and then the person has access to the key, they can equally decrypt your messages and then find out what's actually in them. Okay, so if it's speed, you are going in for symmetric. If it's security and then being safe, you are going in for asymmetric, because there's two keys that are being used in the key exchange. Someone was talking using El Shaddai's profile as if it's assassinating in our territory. And because somebody says if it's assassinating in our territory, we'll give you up. That's what I heard. Okay, I don't know if it's from this side.
Yeah.
Alright, any other questions before so that we continue?
Yes, please.
All right.
Okay, this is my last question. You see the symmetric.
Yeah.
We know it means only one key. So you know it's only one key that is being used for the symmetric messages.
Yeah.
But what if it's because asymmetric? How would you know that this kind of message are supposed to use private key or the public key? How would you
The way you're asking the question, the thing, say maybe it's this way and then it becomes this way. So before any message is being sent, or let's say like you are using a particular platform, right? The algorithms are set, so it doesn't change mid transit.
Okay.
And it's not you are not the one responsible for decrypting the message.
Okay.
Everything is done within what you are using. Okay, so if it's an application you are using and you want to because a message where it's a symmetric, it's a asymmetric algorithm, if it's in an application, the algorithms have already been set in the application and then everything is just working. You as maybe a cyber security. Okay, what's your question?
So the question is, if it is asymmetrical, how do you know that the message that I'm receiving, I supposed to use the private key to encrypt or the public key to separate?
Yeah, so that one Nameka say it's not going to be at your part.
Okay.
That's what I'm saying, that the systems have already been set and then the algorithms have been set in the system. So when the message comes, the system nankasa nim there was here. The only time you actually have to do manual encryption and then decryption is when you personally you want to do it, and then if you are doing it personally, you will be aware of the algorithm, because if you are using asymmetric, there's going to be a key exchange. That means you need the end user's public key. The moment you have a message with a public key, it should tell you that it's asymmetric. So that means you need to decrypt it, you need a private key.
Okay. Okay.
Okay, so there's going to be a recording, so I'll drop the link probably tomorrow. I think Edu Raphael is asking about audio stuff. Yeah. As Magdalene's hand is up again. Let's hear you.
Please, imagine I want to talk to Fatima.
Okay, talk to Fatima.
We want to build our own algorithm.
Yeah.
Using the keys. And I am the one who will build the algorithm.
Yeah.
So I'll create the public key and then the private key. In what way can I share the private key to Fatima without anyone seeing it or knowing about it?
So the way you ask the question about generating the algorithm, if it comes to generating algorithms, you're not talking about private key and then public key here, because algorithm has to do with you actually coming up with the step-by-step process of solving a particular problem or doing something. So if your question is about algorithm, I was thinking that maybe you are coming up with a new encryption algorithm. But if you have to say, so maybe how do you share the keys? If you are doing it personally, like you then Fatima, right, and then you are doing it on your own, you can use any method that a person will share a public key to her, because like I said, the public key is named public because you can even host it on the internet, because it's public. You can host it anywhere for Fatima to go and download it. The only problem is the private key must remain private. That private key, I was say a private key. Don't, under no circumstance should you share the private key with anyone. But the public key, they are waiting to try to book the name. Because based on how the encryption algorithms have been designed, you are supposed to use the public key to encrypt, but that same public key cannot be used to decrypt the message. One, you cannot also generate the private key from the public key. So no matter who finds it, they need the private key, which you are supposed to keep always private. Until they get the private key, they will not be able to decrypt it. Unless say if you are one casa, like I said, you generated your own algorithm and then you didn't find a way, or you didn't know how to do it, and then now your algorithm is weak to the extent that we can generate the private key from the public key, or for some reason we can use your public key to decrypt the message. Clear? Amakunedu, I saw your hands up. Oh yeah, okay.
Hello.
Yeah.
Hello.
Yeah, we are listening.
My question is about the mobile encryption, like messaging on WhatsApp. I think it's end-to-end.
Yeah.
So I'm like, if I send a message to like, but
Yeah.
it encrypts so that nobody encrypts.
Mm-hmm.
So they said there's almost WhatsApp encrypting applications. So this my message as inexorably encrypted.
You're also asking the question that everybody has been wanting to ask. If WhatsApp can see your message in plain sight. Okay, so the thing is, when it comes to those applications, right, you and I do not know if they can see or they can't see. Okay, but the information they are putting out there is that your messages are end-to-end encrypted, which means they can't see your messages, and then it's only the receiver. Yes.
Hello.
Yeah, hello. Amakunadu. Alright, so what the message you are putting out there is that your chats are end-to-end encrypted, which means that WhatsApp nankasa or say the on wankasa kura or chat no. Okay, but the thing is, whether they can see it or they can't see it, no, we don't know because we are not there. We are just basing on the fact that almost it's end-to-end encrypted, no, and then we are using the app. Okay, nobody can prove that unless say maybe you have been able to do your own research and then find out that WhatsApp they can see our messages, which to some extent some people might be able to do it and then prove that WhatsApp can actually see our messages. Because Charlie, the thing is passing through their servers. You don't know the encryption algorithm they are using, unless maybe you decided to read their terms and conditions, which we never read.
Hello.
Yeah. Alright, so if there's no any question, let's continue with the slides. Yeah.
Can you repeat the answer?
Disconnected. So.
And
But
ama kunedu nipa mienu ana.
Yeah, Christian.
Okay, so I was saying that the WhatsApp, whether WhatsApp can read your messages or WhatsApp cannot read your message. Oh, Charlie. Whether WhatsApp can read your messages or they can't read your message is something we wouldn't be able to maybe determine, because they are just saying that your messages are end-to-end encrypted. Unless we are actually there, we can't determine, or unless somebody decides to do his or her own research on WhatsApp to see if it's actually true that they are encrypting our messages and then they themselves they can't see it. Okay, until then we just have to accept the fact that it's end-to-end encrypted and then use the application. Alright, so let's move on to integrity. Now integrity has to do with the genuineness of something. When we say the integrity of something, we're trying to check how real, how genuine, or how authentic something is. That is integrity. Maybe making sure that something is free from modifications or alterations. That is what we mean by integrity under the CIA triad. Now, what do I mean by saying all these things? Okay, so let's say you went to the hospital to do a checkup. Okay, a checkup, any form of checkup, right? And then your result was going to the doctor. So you are going to the doctor to go and get your result, and then she or he is going to write the prescription or like some drugs to go and buy. Okay, now whatever test you went to do was actually negative at the lab, but when you go to the please mute yourself, there's someone. But when you go to the doctor's place, the information there was positive. So the doctor says, maybe Fatima, maybe Ama, test now about positive. Meanwhile, from the lab, the test is negative, but at the doctor's place it's positive. That means the record has either been modified or you have the wrong records at the doctor's place. But we don't have any way to check, because the doctor is seeing the results from the lab and is trusting that the lab is giving her the right result. So she prescribes medicine for you to go and buy for something that is not there. That is actually something we should actually be careful about. So you realize that for at that instance, the information at the doctor is not the original result. It's not the genuine result. It has either been tampered with or someone has made a mistake somewhere. So most of the times, one way people would use to ensure integrity when it comes to file systems, okay, or when it comes to assets like files, folders, and let's say documents on our systems, what they will do is use a method called hashing. Okay, hashing to hash the files and then generate what we call a hash value. Okay, and generate what we call a hash value. Now I'm expecting that you would have most of these things in your assignments when you submit them tomorrow 7 a.m. before 7 a.m. Alright, so a method called hashing, and then it will generate a hash value. Now this hash value is actually the result of you hashing the file. So whatever you get is going to be like something to verify that the file is actually the legitimate file. Now when you hash something, the moment the file is changed, the hash value changes completely. So we are able to verify that, oh, okay, this file has been modified. This file is not the same anymore because we have different hash values. But if you get a file with a hash value and then to verify its integrity, you rehash it again and you get the same hash value, then it means you are holding the authentic or the original file. I don't know if you understand what I'm saying. Do you understand?
Yes, please.
Alright, so let's see a typical example of hashing. So I'm going to use this site called CyberChef. CyberChef. So I've posted the link also in the chat so that maybe anyone interested can also open, and then so this is how CyberChef looks like. Okay, this way. So it's kind of pretty cool and neat. So because it says chef, that is why you have this recipe section here, and then we have bake here. Okay, so it's used for a whole lot of things, right? So you can check the data format, you can do encryption, encoding, you can use it for public key generation and then verification, get a whole lot, networking, date and time, a whole lot of things, right? But since we are talking about hashing, let's click on hashing, and then these are various hashing algorithms under hashing from CyberChef. Okay, so what I'm going to do is just type in a text. This is a test on hashing, like this. Okay, with 3 dots. Then I'm going to take the top hashing algorithms, so the ones at the top. Doesn't mean that these are the top most, but these are just the ones at the top here. Okay, so I'm just going to take MD5 and then hash the text. So it works its magic, and this is the hash for this text. Now whenever I'm sending a message like this to someone, I'll attach the hash value to it, indicating that when the receiver also receive this message, what they should do is they should also hash this file or this message again to see if they will get the same hash value, because the hash values never change. If they get the same hash value, it means that this is the original text. If they get a different hash value, it means that this text has been modified. So for instance, if just between on and hashing I introduce a space, pay attention to the hash value here, see what will happen. Now you see the hash value, even though it might not look like a major change, but you see the hash value here, it has changed completely. Let me copy the current hash value here, paste it. This is the current hash value, and this is the previous hash value with just one space. Now you see what we are having, 2 different hash values, and then this shows you that the file has been modified with. There are other platforms that integrate or use hashing in their products. Okay, so for instance, the website that we download Kali from, which is Kali.org. When you visit Kali.org, you would realize that all their softwares or all the products that they are actually putting out there for download have been hashed, and then the hash values have been also kept around, so that whenever, what it tells you is that to be sure that you are actually downloading the real software, the real products from their site, when you are done downloading it, just hash the file again, and then make sure that you compare the hash values and see if they match. So I go to download, then I come here, so I'm just going to look for one of them. So for instance, this is the ISO installer. This is what enables you to download the file, and this sum value here is the hash value. You click on it, and then you realize this is the hash value for this file. It was generated using the SHA-256 hashing algorithm. So what they are telling you is that after you have downloaded this file, hash it using this algorithm SHA-256, and you should get the same value here. If you don't get the same value, then probably you have either a corrupted download or you've downloaded something different. Yeah, so that is what it means. Okay, now hashing is using various fields. Aside, I'm just doing this to ensure integrity. Most of the times in our systems, right, like where we actually type in username and password to log into systems, our passwords are not stored in what we call the database in plain text. Passwords are not stored in database in plain text. They are actually stored in hashes. So we have our programs, or let's say our code, hash the password using a particular hashing algorithm, and then we store the password hash in the database. That is what happens. So your passwords never get stored in plain text in an application. It's actually being hashed, unless maybe your application is doing its is storing its password in plain text, which I think that is going to be a problem, and you have to run away from that application. Okay, yeah, so it's just your password that are being stored. The reason is hashes don't change until the real value is modified. That is why hashes have been used. If we were to use encryption, there are some encryption algorithms where if you encrypt something now and you encrypt it now again, you get 2 different values. That is why encryption is not used, because of the way the passwords are being used, or the way applications perform the authentication. Any question? Any question? Any question? Today's Stone God didn't come. Mega check. Oh, okay. All right. Any question? If there's no question, I think we have like a couple of things more, and we have 6 minutes.
Yeah,
Boss.
I don't know if you can schedule some 3 minutes and meet the level 200. Is it a criminal some assignment that you are a little bit confused? If you can
Okay.
probably you can end the class. You can end the class report and then you take them through that.
Okay. I mean, if anyone has a question, you can ask. If you don't have a question, so I'll end the recording, and then probably we check the level 200s or more working on.